Good afternoon. My name is Alejandro Valdez. I am here on behalf of my co-principal investigator, Paul de Guzman. He couldn't be here today. My teacher facilitator is Michael Bowen. So we all know things like astronauts get taller in space because there's no force of gravity to counteract their bones and muscles. A lot of the effects of non-standard gravity on the human body has been documented pretty extensively. But in terms of the human reproductive system, we don't know so much because it's not something that astronauts really concern themselves with. But in the future, as space exploration technology advances, the idea of permanent human colonies in space is something that's becoming more and more realistic. So most astronauts today go up into space as colleagues, not as families, but that might change one day, and before that, we're going to need to establish the impact of low gravity environments on the human reproductive system. So this is a brief overview of how fertilization occurs inside the human body. So a woman's ovaries will produce an unfertilized egg, or an oocyte, or oocyte, I'm not sure how it's pronounced. And sperm cells will travel through the uterus and meet the egg inside the fallopian tube. And a single sperm cell will fuse with the egg to produce a newly fertilized egg, a zygote. And over time, genetic material divides and cells replicate to form a primitive multicellular embryo, a blastocyst. And eventually, this blastocyst implants itself into the uterus, commencing pregnancy. We chose the type 2 FME, and in volume 1, we have 4 human egg cells, or ova as they're known. And in the second volume, we have half a milliliter of sperm cells. And we chose a proprietary fertilization medium. It's sort of like a nutrient bath to make sure that cell function is optimal and all that stuff. And it's owned by a company called Vitrolife, and this kind of thing has seen pretty extensive use in real fertility treatments for real people. So we had a pretty good hunch that it would work well. So on the day of arrival to the ISS, so that's day A equals 0, all the astronauts will do is release the clamp on the type 2 FME. And over the course of a few hours, the sperm will gradually travel towards the egg cell. And the egg produces a thermal gradient so that it cools the temperature around it, so that the reaction of the sperm cell to this is that it gradually gravitates towards the egg cell. So the sperm moves in its general direction, and then once it gets close enough, the egg cell makes sure it hits the mark. On arrival of the sample to Earth, we're not sure exactly what stage of development the egg cell will be, but there are a few key indicators of successful fertilization. In the above image, you can see this is the egg in an early stage, so it's pretty much just having been fertilized, and you can see 2 little like circles, spheres or whatever. That's the male and female genetic material. And below is a very early stage of embryo, so that's a while after fertilization. And you can just, the most reliable way is to just use a microscope and look at it and see if the visual indicators are there or not. So we hypothesized that the reduced gravity would have an effect on the fertilization of an egg cell, but there's not a whole lot of background research on this, but what serious is that although lower gravity makes sperm move more freely, which should improve fertility, gravity is also known to disrupt enzymes that are crucial to the fertilization process. So it could go either way. It might turn out worse than inside the body in an ideal environment, or it might turn out better. We couldn't really tell for sure. Unfortunately, we didn't know this at first, but acquiring human samples like this is actually fairly difficult. You have to go through a lot of review processes and stuff. So we haven't made any headway at all on our ground experiment, so we can't report the results of that. We'd like to thank our sponsors. Questions?
My name's Michael from Houston, and you said that you didn't make any headway in terms of your ground experiment, but in conducting a lot of your preliminary research, did you speak with any professionals in this field?
Yeah, I forgot to mention, we consulted a local fertility clinic, and we spoke with one of the MDs over there, and he told us, yeah, it could work, and he was interested in even doing some follow-up research about it. And yeah, but he did tell us that we wouldn't be able to get the samples within a reasonable time frame to perform a flight experiment.
But is he interested in working with you in the future?
Yes, potentially.
Yeah, I have one question. What you're proposing is to fertilize a human egg, which in the womb would grow into a human being. So what are the bioethical issues with that?
Yeah, that's a good question. I'm not a professional, so I couldn't really tell you what the professional opinion of that is. It was certainly a concern. Our understanding was that the egg would not be in a, I guess, like a live state when it returns to Earth, but we didn't get that far enough into our into acquiring samples that became an issue. We're sure it probably would have. We would have been thinking about, okay, there's ethical concerns about this, so can we really go through with this? But yeah, I can't really answer your question in a lot of detail because I don't know.
Okay, thank you very much.